Okay, well, happy Wednesday, guys. Happy Wednesday. And so the warm-up was just looking at a couple pictures and telling me what you see, what you wonder. So that was the first picture. Was that the first one or the second one? Let me see. Oh my gosh, the window closed. All right, give me a second. And here was the other one. I believe that was the second one. All right, so first one, let's see what you guys said. Let's see what you guys said. What did you notice about this picture? What did you wonder? And hopefully you tied it in a little bit to what we've been talking about this past week. Right, what have we been talking about? Someone in the chat, what were we talking about all last week? Something that was a 7th grade standard, but I wanted to review it. Anybody? Anybody? What were we talking about last week? What was the topic last week that I don't know, mister. Ratios. Ratios and what? Wow, nobody? Proportional. Proportions and ratios. Proportions and ratios. Yeah, so hopefully you put a little bit of that into this. Maybe you noticed something like that. Maybe you didn't. That's okay if you didn't. I was hoping you did. So let's see what we see. So this first picture, I had someone say, I noticed numbers and wonder. I noticed numbers. Come on, guys. We need to be specific, more specific than that. Yes, of course there's numbers. Come on. Come on, bro. I wonder if they work the same way as how triangles always equal 180. Well, these aren't angles, are they? These aren't angles. These are the side lengths. And we do know, yes, it is true, the angles of a triangle always equal 180. So that didn't go away. But these are not angles. These are the side lengths. But okay, that's what they wonder. I noticed that the triangle on the left, that's this triangle, is the same thing as the one on the right, but it has been zoomed out and made to look smaller. I wonder why the sides have different measurements. Well, if it's smaller, how do we know that it's the same? Yes, that's smaller, and that's smaller. Then how do you know it's just a zoomed out version of that one on the left? Okay. The triangle on the left is bigger than the triangle on the right. Its sides are also greater too. Well, that's what bigger means, right? Bigger does mean greater. The right side is smaller. Okay. You guys, you need to be a little more specific on your analysis, right? It's like it's kind of like if you watch a football game and then the game's over and they're like, all right, let's analyze what we just saw in the game. And then a guy comes up, well, the winning team scored more points than the losing team, and the losing team lost, and the winning team won. Back to you. Well, no duh, you didn't say anything that we didn't know. Give me some more analysis. Look, what do you notice a little deeper than just that's bigger, that's smaller, right? Now look, I know you're just 10th graders, but you're not just 10th graders. You're getting older, right? You're so close to becoming an adult, so you need to have more of a specific idea of when you look at something, not just, don't be a trumper and just like look at the things superficial and not actually look at the things deeper into it, right? Give me some analysis. Go look a little deeper. Give me more specifics. What do you mean different? What do you mean bigger, smaller? Is there a way that they're bigger, smaller? And if one looks like it's exactly the same as the other, can you compare anything? Can we do anything to compare to make sure that, yeah, it is a smaller version of that one? I noticed 2 triangles. Good, I'm glad. One is smaller than the other, but they both seem to have the same shape. Well, okay. I noticed that they are triangles, and the numbers are going by 5. Ooh, the numbers are going by 5. Okay, now I have someone looking at the numbers and noticing some type of pattern. The numbers are going by 5, and in the small, the numbers are going by 3. Ooh, so we have a number 3 and 5. So they're noticing something. They didn't figure anything out, but that's what they noticed. They didn't tell me what they wondered, but they did notice that these all can be divided by 5, and these all can be divided by 3. Okay, does that mean anything? They are the same triangle, but one on the left is smaller. Really? This one's smaller? I wonder if we have to do something with the smaller triangle. I think the one on the right's the smaller one, right? It's okay. I notice that they're the same picture, but one is smaller, scale, version. Ooh, scale. Okay, that's a word we're going to be talking about today. A scale, okay. Version, and I wonder if it changes the volume. This is a two-dimensional. Two-dimensional figures don't have volume. Three-dimensional figures have volume, right? I can't fill this triangle with water because it's just flat and such. I notice that the figure is the same but more small. I notice that the numbers are the half of the originals. Are they half? Is 15 half of 25? Is 18 half of 30? Is 12 half of 20? No, but even though this person, again, sometimes wrong answers lead to correct thinking, he did start comparing. He looked at that side and compared. Looked at that side and that side and compared. Looked at that side and that side and compared. And he said half, but it was not exactly half, but he is on the right track of we should be comparing the sides. If that's a big triangle and that's a smaller version of the same triangle, let's compare them somehow. I notice they are the same shape, but I wonder why they are different sizes and different letters. I see two triangles with numbers on the sides. Okay, I wonder why one triangle. So maybe I'm not specific enough with you guys. When I say what do you notice, I don't mean what do you notice. I'm kind of asking, again, I'm kind of being a detective, right? And I'm asking people who witnessed what was going on to give me details, right? So that's when I say what do you notice, I want specific. You guys know what specific means, right? Right? But if we're at school and let's say you come over to me like, Mister, that person's bothering me. And I say, which person? And you go, the one over there. Which one? The one with the nose. Oh, the one with the nose? Which person? The one over there. He has two eyes. Okay, can you describe this person more? Um, they're about my age. The one with 10 fingers. They have hair. They're wearing shoes. I think they're wearing clothes. I mean, that's not the kind of description you would give, right? So that's the kind of descriptions I'm seeing here. I need more specifics, right? Give me more description. Look at it. That's why I gave you 7 minutes to look at it and not just say, I see two triangles. Those are numbers. The end. No, you got to tell me, what do you notice about those numbers? What do you notice about those triangles? And some of you are giving me that. I am getting a little bit of that, but I want more. Give me more. I want more. So let's see. Right? I want those details. Image ZXY, that's this one, is the same triangle as TRS, but it's smaller and has been shrunken. Okay, how do you know that? Of course it's smaller. But how do you know it's been shrunken? How do you know this is a shrunken version of this? But you guys are noticing that maybe this is just a zoomed out version of this, or this is a zoomed in version of this. And some people are comparing the sides. That's a good way to look. I notice that they are the same shape but different sizes. I wonder why one is smaller and one is bigger. The image is the same shape but just put into smaller form. I wonder what is the formula for scaling down the object. Ooh, scaling down the object. So there you go. So now we hear the word scale again. Okay, so let's go to the next picture. And let's see what people say there. I notice there are numbers. Okay, good. There are numbers. And one of them are the same. Okay, one of them, so 36 and 36. So you do see two numbers that are the same. Good. So you're looking at one triangle and comparing it to the other. Good job. I wonder why they aren't in the triangle and how there's math here. Okay. I notice that for points on the smaller figure, like for example A and point J. Okay, for example A, the difference between point A and point J is. Well, you can't find the difference of points, right? Because point is just a point, has no measurement. We actually got to look at like AC or AB and compare it to JK or JL or KL. right? We can't compare points because you can't really measure points. But you're on the right track. Yeah, I think you're talking about sides also. I see two triangles with the same shape but different lengths of the sides. I wonder, will the first triangle be exactly like the second one if you were to enlarge it? So there you go. So if you get this triangle and you zoomed in, would it lie exactly on top of this one? Okay, is this just a smaller version, a proportionally, not skewed or not, what was that word we used when we squished the rhino? Forgot what word we used, but distorted, there you go. Is that a distorted or is it an actual, if I zoom in, it can fit right exactly over this? So you're asking, some of you are asking the right questions. Some of you are just looking at it and going, yeah, let me just finish this really quick. Yeah, I see numbers, I see a triangle. So some of you are looking at that, you're comparing, you're saying scaled down, bigger version. Okay, so you're looking at half of the other ones. Okay, so that's exactly what we're going to be talking about today. When you have two figures, and one is just a smaller version of the other, it's proportional to the other one, and it fits on top. If you zoom in, and it'll fit on top of the bigger version. Those are called similar polygons, similar shapes, similar figures, right? Similar figures. Okay, that means they are the same, just a smaller or larger version. Okay, so if you go to our Schoology, and again, I'm going to tell you, like I always do, go to our course, go to week 8. Yes, we are in week 8. And then you go to similar polygon notes, right? Yes, it says due today. You do not turn in notes. It just says due today because I have to put it as an assignment. For those of you that like Kami, you can use Kami to take your notes. Okay, so you click on here, and you'll see it. Now next to view, again, this is on my iPad, so Kami doesn't work the same on the computer as it does on my iPad. Next to view, you would see open with Kami. You can open with Kami, and I know some of you take your notes on Kami. There you go. Others of you just like to click on this and have it in a tab and just have it on the side of you while you're doing it. Others of you like to print it out. Again, some of you print it out for your friends also, so you might want to do that today and then maybe drive by and drop it in their mailbox and then get back in your car and then wave from your car to their yard and say hey and have a little conversation. And then go back. Okay, so however you do it, I'm going to give you a couple minutes to go ahead and get your notes ready, and then we will start taking notes. Okay, so I'll give you a couple of minutes. Okay, does anyone need more time to get their notes straight? I know some of you just take notes. You just watch me now, and then you write them down later. Some of you watch the video later. Some of you just watch pieces of the video later to fill in some blanks. Some of you use your handy dandy notebook, right? Notebook. All right. Any questions before we start? Everyone set? Come on, guys. When I ask a question, can you at least give me a thumbs up or a happy face or something? You have these reactions on Zoom. I need some type of reaction because you don't have your cameras on. There you go. I got a thumbs up from Emily. Good job. Anyone else? Thumbs up. Okay, I need to see because yes, I see a yes there. Yes, okay. I need to see these reactions from you. I need some type of participation if you're not going to turn your cameras. And I can't record your voices. Okay. I got a party. No, hold on. I don't have to do that. I can just do this. There you go. Okay, thank you. So please, when I ask a question, oh, wait, someone said no. Okay, they went back to yes. Wait, they went back to no. Yes, come on. Now they're playing with me now. All right. All right, so similar polygons. So this is exactly what you're talking about. Even though some of you weren't specific, I think most of you noticed that the two shapes, one was just a smaller version of the other, or one was a bigger version, depending on which way you're looking at it. And you can look at it both ways. And that's going to be important when we talk about it. Which way are you looking at it? Did you go from the big one to the small one, meaning it shrank? Or did you go from the small one to the big one, meaning it got enlarged? Okay? And we call this similar polygons. So like, you guys see this right here? You guys see where it says similar polygons? Right? You see these words right here now I'm going to zoom in on them. Now, does it look exactly the same? Yeah, it does. It's just bigger. Right? Now it's smaller, but it's exactly the same thing. You notice it as the same thing. And when you have two things that are the same, but one's larger and one's smaller, we call those similar. Okay? So let's give a definition. Again, we are starting a new topic. I'm gonna let you know, when you start a new topic, the beginning stuff is hugely important. There's usually a box that you have to go back to throughout the lesson. Whenever you go throughout the lesson and do problems, there's usually a box that's very important that you got to go back and say, oh, okay, that's what that means. Okay, so this is the time where if you get confused, especially in the beginning, you need to ask. Because if you do not, then the rest of the lesson is going to be, right? It's kind of like if you're walking downstairs. If you mess up on those first couple of steps, you may mess up on the rest of the steps and just eat it and fall down the rest of the steps. And then first, if you do that in school, everyone's going to look and make sure you're okay. Once you're okay, then everyone laughs at you, right? You got to make sure you're okay first before they laugh at you. You can't laugh first. That's very bad form, guys. If someone falls down the stairs, don't laugh right away. Make sure they're okay. Once you know they're okay, then you can laugh. Okay, so it's the same thing here. These are the first steps of our new lesson. Right? It's the beginning stuff. We're defining stuff. We're introducing stuff, new vocabulary, new things. And if you don't understand something, you need to stop me and say, wait. So all of you people, all of those people that have sent me messages saying, Mister, I want to do better. Mister, I want to try harder. Mister, I've been slacking off. And this is the time where you have to ask questions. Because those of you that really mean it, let me see some action. Because words mean nothing to me. I don't know if you know me by now, but like I always tell my boys, I don't like to hear the word sorry. The word sorry means nothing to me, right? That's not an apology. Sorry is when you show that you're sorry, right? So all of you, the people that sent me messages, Mister, I'm going to try harder. Mister, I'm going to do better. Those of you that called your parents and like, oh, Mister, I got in trouble, but now, yeah, I'm going to do better. Okay, those are words. I don't believe if any student tells me that, I'm going to do better. It's not that I don't believe you. It's just, okay, those are words. I don't mean nothing to me. Let me see it, and this is what I'm talking about. So if you get confused, yeah, I mean, you can say sorry. Some people accept the word sorry. I'm just a person that doesn't like the word sorry because I want to see it. I don't want to hear it. I want to see sorry. And the way you show sorry, or the way you show that you're going to do something, is you actually do it. Right? You actually do it. So, please. So polygon, so here's the definition. Similar polygons are polygons with the same what and different what. Anyone have a guess? They are the same shape. Very good. Good job. They have the same shape, and that's what we've all been saying, right? They have the same shape, but what's different about them? They have the same shape, but different size. Very good. Right? That makes sense. That makes sense. That we've been saying that. They have the same shape, they're just different sizes. Okay? And then there's two things we're going to look at to know if polygons are similar. There's two things we're going to look at. Now, I'm going to draw a polygon. Let me see if I have this tool right here. It's going to look great. Oh, didn't even finish. Hold on. There you go. There's a triangle. Look at the angles. I want you to focus on the angles. When I zoom in, or I zoom out, zoom in, zoom out, what do you notice about those angles? Do they get bigger? Do they get smaller? Do they stay the same? What happens with those angles? So there's the big version of my triangle. There's the little version of my triangle. What do you notice about the angles, the ones I did in blue? They get smaller? Anyone want to say anything else? Anyone have a guess? What happens with angles? Do they get bigger? Do they get smaller? Or do they stay the same? The same. So someone said smaller, someone said the same. Does anyone think they get bigger? Anyone want to agree or disagree? Someone else said the same. Someone else said the same. Someone said no. Someone said no. So actually, because if the angles changed, then you'd have a different shape, right? If the angles changed, you'd have a different shape. Those angles stay exactly the same. The sides change length, but the angle, this part right here, does not change. Because if it did change, and let's say it did change, let's say we had a different angle, that's not the same shape, is it? Look what happened to the angle. The angle got bigger. Or what if I made the angle smaller? Right. When I change the angle, I change the shape. You guys notice that? When I change the angle, I change the shape of something. Right? Pick up your phone right now. Look at your phone. Look at the corner of your phone. Same angle. If you have a big phone or a small phone. Oh, I'm not on camera, am I? I'm showing you. If you have a big phone or a small phone, right, that angle stays the same. Imagine if you change the angle of your phone, you'd have a different shaped phone. It wouldn't be rectangular. Does that make sense? So that's the first thing of similar polygons. All corresponding angles are congruent. So between the small shape and the big shape, the angles stay the same. The angles are congruent. All matching angles. Remember, corresponding just means matching, right? Okay, someone said, Mister, can you write better? Because that was kind of sloppy. I apologize. Yes, I will write better. I did that kind of fast. Thank you for letting me know in the chat. All corresponding angles are congruent. And all corresponding means is matching. Okay, is that writing better? I'm sorry, yes. Sometimes when I write fast, it's very sloppy. Sometimes when I write fast, it's very sloppy. I told you guys a story, right? I wrote a note for a student one time, and I said, give this to your parents. And then they came back the next day, they're like, Mister, you need to rewrite this note because my parents don't believe this was written by a teacher. I'm like, what are you talking about? They said, yeah, it's too sloppy. They said they thought it was written by a student. So, yes, when I write fast, I write very sloppy. Thank you, person in the chat who told me, Mister. Yes, that does say matching, right? Corresponding means matching. Is that not neat enough? I'm sorry. So yes, I'm telling you, I don't get butthurt. I've been telling you this all year. If there's something on here that that you don't understand or is not clear, or even my writing is bad, let me know. Let me know. I will not get butthurt. I will fix it for you. I'm not doing this for me. I'm doing this for you. Okay, so now the angles are congruent, but we know the sides aren't congruent, right? Because one's bigger, one's smaller. One's bigger, one's smaller. So what can we say about the sides? We can say all corresponding sides are not congruent because one's bigger, one's smaller, but they grow at the same rate, right? Okay, so we can say the corresponding sides are what? If they're growing at the same rate, they're growing at the same, what is rate? What's another word for rate that we've been talking about this past week? If they grow at the same rate, that means they grow with the same, what's the word? Ratio, right? So if you grow at the same ratio, if this side and this side have the same ratios, that means two ratios are equal. What do we call two ratios that are equal? Oh, come on, people. What are two ratios that are equal? Come on, people. You're going to make me cry. Proportions. Yes, thank you. So the corresponding sides have the same proportions, have the same ratios, so they are proportional. Okay? Like if a triangle is, like someone said earlier, the triangle is double the other triangle, well, that would be a 2-to-1 ratio, right? A 2-to-1 ratio, or you can say a 1-to-2 ratio, depending on which one you're talking about, and we will be discussing that, right? It does, the order does matter, which one you're talking about first. So some people said this word, right? This ratio between the two polygons, this ratio of corresponding sides. So we're going to find a ratio. Is it 2 to 1? Is it 5? If we make it 5 times bigger, it's 5 to 1. Right? If we make it 1.5 times bigger, it's 3 to 2. Okay, that kind. This is called your scale factor. Right? What's the scale factor? A 2 to 1 ratio. Oh, okay. So this is those of you that collect figures. Do I have one around here? I collect figures too. Sometimes you have these model cars. You ever see these model cars? Right? And it says it's to scale. Whenever they say it's to scale, that means it's proportional. That means they're basically saying it's a similar. It's similar. It's just a smaller version. Anyone ever do the small little model cars? Or there's other figures too. Like they do figures of sports figures, right? Or wrestlers. And it says it's drawn to scale. That means it's proportional. And then they give you the scale factor. Like it's a 5 to 1. Right? You guys ever see that? Yeah, right? Yeah, you guys seen that? Yeah, so that's exactly what they're talking about. They're giving you the scale factor. Okay. And then one last thing before we leave today, and we'll practice some problems tomorrow. We'll look at some actual polygons that are similar. We can also say that their perimeters are also proportional. So if you add up the distance around the whole thing, those are also the same ratio. They are also proportional. Perimeter, remember, perimeter means distance around polygon, right? So you're just adding up all the sides. All right, this is it. This is all the definition of what similar polygons are. We will actually do some problems and look for scale factors and see what these ratios are starting tomorrow. But this is the basic of what a similar polygon is, and you guys have seen it a million times. Okay. So if there's no questions, yes, we will have homework. Yes, we will have classwork. It's not on Schoology yet because I have not put it up yet. Okay. Scale factor. The scale factor is just the ratio between the two shapes, between the two polygons. Right? You just got to find that ratio, and we'll get into actual numbers tomorrow. But that's all it is. If I have a model car, it's not a real car. I can't really fit in there, can I? No. But if you look at the scale factor on the box, and I'll show you some pictures tomorrow, it might say it's a 20 to 1 scale factor, meaning a real car is 20 times bigger. So if I find the length of a side of the small car, in order to get the real length of the big car, I got to multiply by 20. Ratio is just numbers, right? If I the last bullet point, perimeters. So yeah, scale factor just means what is the ratio between the two objects? Is it 2 to 1? Like if this length is 2, then that one is 1. That means it's half. Is it 5 to 1? That kind of stuff. So we're going to look at actual. So if you look at these two, we're going to look at these tomorrow. This side to this side. How does it grow? Do I multiply by 2? Well, if this is 10 and I multiply by 2, this would be 20, wouldn't it? So that's not the ratio. It's something else. Well, it's not half because that's 50. So we're going to look at how do we find these ratios. Okay, scale factor is just how much bigger is it? By what scale factor? What ratio? And we'll talk more about that tomorrow because class is done. So everyone take care. I will see you tomorrow. We will go more into this. Make sure you copy this down. And if you don't have any questions, have a great day. Have a great day. And then let me zoom in. Someone said it's a little blurry. I can zoom in. Those of you that are still copying. Have a great day, and I will see you tomorrow. Those of you that are not 100% clear on this, it's okay. It'll become more clear as we do problems because we haven't done any actual problems. This is all just explanation, right? Definitions. So take care. See you tomorrow.